Hello and welcome to this repair tutorial, and today we're going to look at a Yamaha A-S201. This unit is available today, so you can purchase it, and in the UK retails for approximately £299, but there's also a larger version which is the S501, and that's approximately £200 more, so you're just shy of £500. When you look at the design of the amplifier cosmetically from the front fascia, it's extremely clean. You have the single standby button which is on the left hand side, followed by the 1/4" headphone jack socket, and then you have the ability to select speaker A or B, or if you're using headphones then you can deselect and the internal relays will disengage, effectively muting the speakers. But if you rotate the volume control to its absolute minimum, it will also place the amplifier in mute effectively. And then for your bass and treble control settings, you just have a set of push buttons. So as soon as you select them, what will happen is it comes as a description on the display, so it will say treble or bass, and then you just increment or decrement on the plus or minus keys. And then for your input selection, very easy to do, it's just simply toggling using the push buttons there backwards and forwards. And then you also have a pure direct mode, which effectively is just cancelling out the tone control circuits. And the volume control is not using a potentiometer. What he uses is a encoder, which is very, very common. We'll sort of go into that in a little bit more detail concerning some of the work that was carried out. The amplifier also comes with a remote control unit, so I wouldn't say it's like the most sort of expensive design. I've seen probably better cosmetically and sort of ergonomically designed remote controls, probably from amplifiers which retail really at a fraction of the cost, but that's what it is. And you have all the ability to control it, completely remote. With the volume control, because it's an encoder, it's not motorized, so you'll see no volume control, movement. You'll just simply see on the illuminated display if you're making any changes. Now, for the service manual, it is extremely detailed, so you can do a lot of sort of auto diagnostics, depending on what sort of nature of fault you have with the amplifier. But what's sort of unusual as well is you won't find on the circuit schematic, for example, the bias settings. The resistors on the board sort of set the bias automatically. So before we sort of get into the fault description, let's just sort of have a look at the general specifications. So you can see here for RMS power output, we're looking at 100 watts per channel, and then that will go into 2 times 8-ohm speakers. But this will increase up to 115 watts per channel if you connect 4 ohms. And as I said earlier, you also have 2 sets of speakers, so A or B. But what's an interesting and nice feature to see is that it also supports bi-wiring, and there's many people out there who have purchased amplifiers, sort of in the early 80s, like the Cambridge series, which also supported bi-wiring as well. And then total harmonic distortion at a frequency of 1 kilohertz comes in at 0.7% with a 4 ohm speaker load. Sorry, it's just for a 4 ohm speaker load, and then 0.08%. And then frequency response is standard, so that's 20 hertz to 20 kilohertz. And then input sensitivity, because you can directly connect a moving magnet type cartridge for your record player directly, then you're looking at 10 millivolts at 47 k ohms resistance. And then for your remaining, what I term as line inputs, CD tuner, you have a network connection, line and line 2, that's 500 millivolts at 47 k ohm. And you also have the ability to have record out, and that gives you 500 millivolts. Now the amplifier is a decent weight, so it's coming in at 6.7 kilograms, and then overall dimensions, this is including the feet that you're seeing here on the photograph. Height wise it's 435 millimeters, and then width is 141, and 330 millimeters then is your depth. So what was the issue when the amplifier came into the workshop? Well, the first thing was that if you attempted to switch it out of standby mode, the amplifier would simply switch back then to protection mode. So you knew, this wasn't something like a soft fault that you could clear. It was clearly indicating that you had a hardware problem or failure. Now, what I'm showing you here is the main circuit board. Now, in terms of design, really pretty much most of the electronics is on the main board. Bizarrely, you can actually purchase this complete board assembly as a replacement part, but I've sort of said this on previous tutorials. What you'll find is that the retail price for the board is nearly as much as the amplifier. So that's a bit of an head scratcher, and I've said this many times. Why would you make parts available which are as much as the amplifier? It just sort of defeats the object. But don't worry about that. We get into the repair here, and we were able to sort of fix the board. And then the other thing that you have is the main power transformer. And again, that's something to highlight. I have seen both the 501 and the 201 appear in the workshop with open circuit power transformer. So if the amplifier appears to switch into protection mode, before you sort of delve into the main circuit board for the amplifier, it's always worthwhile just checking the primary winding on those transformers just to make sure that that's not the issue, but it wasn't in this case. So how do you actually strip down the amplifier? Well, it's very, very easy. It's almost like modular in construction. And the startup power supply is part of the main amplifier board, so that's not separate. And also the input protection fuse. Now, as the input protection fuse had not blown, then the power is reaching the startup supply. And, of course, the amplifier was functioning because it's fully microprocessor based. But as it attempted to come out, standby mode, it just flicked back. So, okay, what's the issue and what do you see? So visual inspection, as always, you can sometimes use your sniffer. If you sort of open up amplifiers, sometimes you can detect maybe if there's a burnout component. And then early indications that you had an issue, as I'm showing, what you're seeing here is some cardboard. And you probably think, well, how does that relate to the fault that you're sort of going to get into here? What's the relevance of the cardboard? Well, the cardboard has come from one of the electrolytic capacitors. And from time to time you do see this. If a capacitor has been overvoltaged, it depends how it fails. And I've covered this in previous tutorials, and I will put a link in the description. Sometimes you may have like a pattern on the top, which is like a burst top plate, or in some cases they will vent out of the bottom. So what has happened is that it's gone over voltage, over pressurized. The safety operation has come in. And what it's done is it's blown out of the bottom of the capacitor the cardboard, which is used as the dielectric or the insulator within the capacitor. And you can see that it's sort of covering itself around some of the legs of one of the transistors. So that's an early indication. And then what you also see as well are a number of burnt out resistors. So straight away you know that there is an electronics issue, and you need to get in there then to repair it. So rather than sort of try and fault find the board in situ with the amplifier chassis, remove the back cover plate, and then what you can then do is you can remove the fixing screws from the amp board. And there's also a side fixing plate which just carries the ribbon cable from the front display stripe micro board. Once you've disconnected the power connectors from the transformer, and there's also as well the headphone jack cable, you can just lift it out of the chassis, put that to one side, and then you're free then to work on the circuit board. Now what I will say is what you see from the top is really only a fraction of the circuit. What's mounted on the top of the board are components which cannot be surface mount because the amount of current that they're handling, it's just unsuitable. So I tend to term this really as more like a hybrid board. You have a combination of two types of design. One, conventional discrete components, and then when you turn the board over, as I'm showing, you can then see that there is a lot of surface mount devices, and these devices are both resistors, capacitors, transistors and diodes. So when you undertake the repair work, and again I'll put the link in, or I'll put the link in the description, don't even consider working on the amplifier if you don't have a dim bulb tester, okay? Because once you've fault found the amplifier board and you feel comfortable then to put it back in and then to test it, if inadvertently you have missed a component, then it could lead to catastrophic failure. So what you want to have is that series current limiter, which will prevent that. And if the light bulb lights very brightly, and what you'll tend to find is the amplifier tries to switch out of standby mode, then it will trip back into protection mode, backwards and forwards as you toggle the power or the standby button, or it will just cycle itself once it's pressed. You have to have the protection, okay? You must do that, and the bulb will protect you. So in terms of fault finding, it's really a methodical task. All right, so what I'll do first of all, as I did with this amplifier, is to look at the reason for the failure. Now, the second most common issue that you will find is that you will have a failure of one of the channels. So here it is the right channel that has failed, and then what I'm focusing on is to just make a measurement, resistance measurement, on the output transistors which are mounted on the heatsink. And again, I'm highlighting it here, and straight away I knew, before even measuring, that the output transistors would be short circuit, and that's what we found. But undertake the work to replace the output transistors, but again use genuine original type. I've mentioned this many times in all the tutorials. The market is flooded with counterfeit devices, so go source genuine originals, and then you know that when you come to power up the amplifier, you're not going to have any issues with fake components. The next thing that I looked to do was to replace the electrolytic capacitor, and I'll come to what components and what values or what type they were in a little while. Once the capacitor was replaced, I also then focused on the resistors which had burnt out, and then also as well the discrete transistors. And there was a number of those transistors, which are the higher power type transistors, which were non-surface mount, which had failed short circuit. So you knew straight away the reason why the capacitor popped was because it had been subjected to an overvoltage situation. Once those components were replaced, the next part is to turn the board over, and then what you're aiming to do is to work your way through. And again, you can refer to the schematic as well if you wish, but you need to focus then on the underneath of the board, because this is where you will find the surface mount devices. So what I'm sharing now is the extract from the service manual, and you can see that this is for the right channel, and it's both the input stage of the amplifier, the voltage, driver and output stages. Now when this amplifier failed, you can see what I've done is I've ring circled each one of the failed components, and it's quite extensive. So I would tend to say that this is more of a catastrophic failure. When the output transistors went short circuit, this is what you found. So just on the bottom right, you can see that I've detailed the components that were replaced. And what I'm also indicating is the ones which are SMD, or surface mount devices. So the two power output transistors are Q115 and Q116, and they are 2SC4468, identical. And then what you can see is D104, and that is a surface mount BAV103. And then as you work down, you have Q111, and Q111 is one of the driver transistors, and that's a 2SB631. And then you also had a failure of Q106, which is a 2SC3206. And then towards the front end, what you've also got are two long tail pair transistors, and both of these are surface mount devices. So those transistors there are Q102 and Q104, and when you're metering them, you could see clearly that they were short circuit. And if you wanted to use a reference, you can compare it then with a working left channel. Again, no power applied, you're just simply using resistance measurements. And then I'll bring your attention also to Q108, because this is very important. Q108, during the initial repair, I missed it. So I replaced all of the other components, including R112, which is 820 ohms, and R116, which is 8.2 k ohms, and then also R141, 330 ohms, and then R145, which is 2.2 ohms. What was interesting is that the emitter resistors themselves are not failed, and those are the white ceramic power resistors on the board. That resistor had not gone open circuit or even changed in value. Once I'd done the repair and I replaced those components, this is the point that I made earlier. When I replaced the board and then I repowered back powered the amplifier back up, it got into a cyclic mode. So literally it's just switching on and off as it's trying to power up or initialize, and it was just overvolting. The protection circuit was preventing it, from coming out of startup or entering past startup mode. Now that told me straight away that I'd missed something. So what I had to do was then to remove the board, and again I had to spend time then to just check. And what was interesting with Q108 was I was probably looking more so for a short circuit on a transistor, and I thought, well, I've found all of those. There can't be anything else left. And then what I did find, and of course these are measured in circuit because they're SMD devices. You know, I wasn't desoldering them at this point. I found that Q108 was actually open circuit from base to collector, and that was the fault. So being open circuit. So once that was then replaced, I reinstalled the board. And then I could then power it back up again, and sure enough, by the gimbal tester, it switched out of standby mode and the amplifier within about 4 to 5 seconds. When I selected the speaker selection relay, you heard it change over, and all was good. And it was just a case then of measuring the resistance, the DC offset on the rear terminals. And for the repair channel, it was very low, probably about 4.2 millivolts. And then for the left channel, it was probably slightly higher, about 6.1 millivolts. Now, I've emphasised these through previous repair tutorials, and I tend to use a term which is about making the time and taking the time. And the reason why that's important is when you're working on any kind of electronic equipment, you know, just make the time, all right? Don't try and rush it, or you know, you say, well, I found some of the faulty components, so that must be everything. You know, you've got to go through this methodically. And as I've highlighted, I also missed one of the components. And if I just rushed through and then, you know, hadn't bothered using the gimbal tester, I'll tell you now that would have been a complete rework of all those components which had failed in the first place. So just make sure you do that. And then also as well, before you sort of initialize the amplifier out into test mode, just verify your work. It's very easy maybe to have missed something, or maybe you had a solder bridge. And when you're doing SMD devices, you know, you've got to make sure those are on the pads and nothing is sort of broken away. What I will say, the circuit board quality is very good on this amplifier. It's not like some amplifiers where there's been a cost cutting exercise, and as soon as you touch, you know, with a hot nozzle or maybe a soldering iron, the pad starts to lift away from the board. That was not the case. Now, the next thing I want to sort of talk to you about is the volume control encoder. Now, I've mentioned this on previous tutorials. For this amplifier, if you tried to rotate it left or right, it was extremely stiff to move that. And the reason for that is that the original lubricating grease has dried out and it's just become rock solid, almost like a kind of a semi-permanent glue. So, very, very easy as I show. You don't need to desolder the encoder from the circuit board. Here it's just held in place with one fixing screw, and once you remove it, you can just pry back the the tabs. That's probably the best word. There's 4 tabs that just hold the front of the encoder in place, and then once I just bend it back, just be careful because you know you don't want to bend it back too far and maybe they snap off. Just enough so you can remove the front assembly, and then what you can see is just laid to one side, and then you can see the encoder part there. So what I do here, there wasn't very much oxidization on the contacts, but I still cleaned it with a fiberglass pencil. Don't use sandpaper, always use something like fiberglass pencil, which is not sort of abrasive as such. And then what I do is I just clean off the original lubricating grease, and then I'll reapply some deoxide grease just onto there because it's metal contact, so it gives you that nice slip grease. And then it also provides for you some longevity as well. And then it's a simple matter of just putting the front of the encoder back on, just take a pair of long nose pliers and then just squeeze down the tabs again, and you know you'll get really precise operation. The thing with these types of faults, and again there's a link in the video description, and I've covered encoders before, what you can find is that maybe you adjust the volume control from the remote control and it works perfectly, increments, decrements, doesn't skip. But then a customer may report that if they operate it from the volume control, it seems erratic or unstable, maybe it jumps a number of digits, or they're not getting a clean switch. For encoders which are used for input selections, it's a bit of a nightmare because what you'll find is random input switching, but not here. But for the volume control, if you see that erratic behavior, it's going to be the encoder. It's not nothing to do with the microprocessor. Just take it apart and then do the full clean then. So kind of an interesting repair, but this isn't the first time I've seen this. It's the first one which I've done a repair description for, but if you use the landing site for the channel, and then you just use the search feature and type in Yamaha A-S201 or 501, you will find full descriptions, backdrop videos for both amplifiers where either I've changed the power transformer or there's been a failure of channel. And it tends to be, for whatever reason, the right channel where you have this catastrophic failure. But as I say, you know, there's a lot of sort of insight here. And then in terms of sort of finishing off, this amplifier, I'd seen probably reasonable amount of use, but it was just a case just cleaning up the headphone socket, you know, just get some deoxit in there, plug your headphones in, you know, operate it a number of times. And as I said, there wasn't sort of any bias adjustment to be made here. It's all sort of preset on the board, and there wasn't any high margin, you know, of DC offset. So it's just a case of just simply cleaning the amplifier, and then you do a full, you know, operational check as well. For the input selection, it's not mechanical, it's all electronic, and you have a dedicated IC on there for input selection. You know, it's overall it's a nice quality amplifier, and quite an interesting repair as well. So that sort of brings us to a close now. So as always, I really do appreciate you stopping by and listening to this tutorial. And what I would say is, if you have any questions or you need any guidance, support or help, just send an email to audioamplifierservicing@aol.com, and I'll be quite happy to respond back to you, normally same day, and then provide you any guidance or support. Or you can leave comments in the chat for the respective repair, and again I'll pick those up and then respond back to you. So until the next time, I wish you all the very best. Thanks a lot. Bye bye.